Alright, let's go over this problem. So, first thing we talked about, you could, because it's already factored, you can just graph this using multiplicity. What does that mean? I can just solve for my setting them equal to 0 using the zero product rule. Raise your hand if you did that. So once I subtract 4, I get x equals negative 4. And over here, I get what? Raise your hand if you got x equals positive 2. Now you can talk about its multiplicity. Class, this expression, x equals negative 4, has a multiplicity of what? It has a 2. So your multiplicity is a 2. Is that number even or odd? This is an even. What do you do at even? It's gonna kiss. How about the multiplicity at x equals 2? It's a 1. Even or odd? What do you do there? So I have that information, right? We also know that our basic graph is x to the squared times x. What are you doing? Times the negative 1. So that'll give me basically a graph that has the a value that's negative 1 and x to the third. So our graph is gonna, x to the third starts down, ends up, and because it's negative, it's gonna change, right? Starts up, ends, ends down. So let's go ahead and graph that. Is it okay back there? Yeah. So when I graph this, then at x equals negative 4, and then that's x equals negative 4, and then at x equals 2, so then I just need to draw a graph through this. So I'm going to start up and down. At x equals negative 4, I'm going to bounce off, or there's my kiss. And then I have to come back through x equals 2. Now if you expanded this, you could have actually graphed by that y-intercept. So I'm not actually quite sure where that y-intercept is, but you could have graphed it. So if I look at this graph, class, let's answer those questions. Does it look to be an even function? How about odd? Yep. Well, I have a bounce here, right? A kiss there, but do I have one on this side? No, so you don't have, they're in quadrant 4. There's nothing. So it's a neither. Raise your hand if you got neither. Let's verify that algebraically. So I'm just going to put in a negative x for each of those. Here I'm going to multiply x minus 4 times x minus 4, or x, negative x plus 4 and a negative x plus 4. Jackie, negative x times negative x. Negative x times 4, Jackie. Alexa, negative x times 4. Alexa, 4 times 4. So when I combine like terms, I get x squared minus 8x plus 16. And now I can just take that right at above. And now I'm going to multiply that by negative x minus 2. Draw my boxes here. Uh-oh, don't do that. Robert, negative x times x squared. Negative x to the third. Robert, negative x times negative 8x. Yep. Robert, negative x times 16. Negative 16x. Sophia, x squared times negative 2. Let's see, negative 2 times negative 8x. Janet, negative 2 times 16. So this would not be fun to verify, because then our answer, negative x cubed plus 6x squared minus 32. That's if you just substituted negative x, and then I forgot to do the negative sign in front. So then you would change all of those. So our ultimate answer, if you did substitute negative x, would be x cubed minus 6x squared plus 32. Now to double check that algebraically, I would have to go back to the other function and actually distribute all of those out. Does that make sense? Just to check, and you would recognize we already know that the answer is what, class? Neither. It's not going to change. What's the leading coefficient for this problem? The leading coefficient is a negative. What does that leading coefficient do? It's changing it from a negative, starts down, ends up, to starts up, ends down. Does that make sense? Is it an even or odd polynomial? Degree polynomial. Well, you're looking at the degree. What's the highest degree there? The one we just expanded? That would be to the third power. So that's an odd degree function. Not an odd function, odd degree. That's degree means exponent. There's our graph. We did it on the last one. And let's just say we had to write our end behavior as x approaches what? That's what our graph looked like. We always write positive. F of x approaches what? So we're going right to left to right, so it ends up down. So that would be negative infinity. As x approaches negative infinity, so we're going now right to left. How does it end? It ends up here, so that would be positive infinity.